Hey you guys, here's your FLT for the day. We're jumping into section 2.3, but we'll give you the heading as soon as we scroll down a little bit more, okay? Go ahead and write down your FLT and play when you're ready. So given a function here, I will be able to find the derivative just like last time, but now it's by using the product rule and quotient rule efficiently. More about the efficient part later, okay? So you're walking away with this. You want to know how to apply the product rule, whatever that is, and the quotient rule, whatever that is, but also efficiently. So kind of along the lines of, when you guys were dealing with solving quadratic equations way back in the day, all right? There were many different ways of solving a quadratic. So for instance, x squared plus 4x plus 3, okay? Now, you could do this in many different ways. You could solve it by factoring. You could solve it by completing the square, or you can even solve it using the quadratic formula, right? But based on how it looks, the most efficient way is probably just to factor and then use your zero product property, and then you could solve it there. Okay, so you not only want to know all of the rules, but you want to know technique as well. You want to know which method would give you the answer the fastest. So we're looking for a lot of efficiency here, okay? So here we go. Just keep that in the back of your mind. So let's recap, okay? Recall the sum rule. It's not really a rule because it's so intuitive, okay? So remember, the derivative of a sum is just the sum of each derivative, right? The derivative of a difference is just the difference of each derivative. Now the product rule, the derivative of a product is, now some of you are probably thinking, the product of each derivative. And that's where it goes sour, okay? Some people think it's the derivative of, the product of each derivative. Don't write this down. That's a big no-no. Okay? There's actually a rule for it. And there is a proof to it, but really it's not important for me to go over. Okay? Now, if you're really curious about how the product rule came about, I'll be happy to show you the proof. You can even watch videos on your own if you'd like. There are some things that are worth going over as a proof and some things that aren't. Okay? So, but just understand that this came from a very logical approach, okay? So first thing I want you to do is this, okay? I'm going to go ahead and rewrite this so that it's a little bit easier on the eyes, okay? So what I do want you to write down is everything in blue right here, okay? So the derivative of f times g. Okay? We're going to ignore the, of x part, okay? Just to make it a little bit easier. Okay, so here's what you do. First, just write it down, and then we'll talk about how we're going to memorize this here, okay? All right, go ahead and write that down. Highlight it, very important. Here's how you remember it, and you got to say it out loud, okay? Otherwise, it's not going to stick. So if we have two functions and we're multiplying it together, right? If we have a product and we're taking the derivative, the way you remember this is, let's give it some names. Let's call this the first, and let's call this the second. Obviously, the function that appears first will be called first, and the second function will be the second function, okay? So the way you read this is, the product rule is the first times the derivative of the second plus the second times the derivative of the first. Okay, it takes some getting used to, so I'll say it a couple times. It's the first times the derivative of the second plus the second times the derivative of the first. It's like they're taking turns in terms of who's going to have the derivative, right? So notice how at the beginning, it's just the first, and then the second one gets the derivative, and then plus the second one, now the first one gets the derivative, okay? So here's what I want to say about this. So first off, pause and say it to yourself, okay? I'll say it one more time. It's the first times the derivative of the second plus the second times derivative of the first, okay? Say it a couple times and then press play again. Okay, so here's what usually happens. Some of you may mix this up, okay? Some of you may say it's the derivative of the first times the second plus the derivative of the second times the first, okay? Now, if you understand how operations work, okay? Multiplication is commutative, meaning the order doesn't matter. 3 times 4 is the same thing as 4 times 3, right? So this right here is really this right here, okay? And same reasons, f times g prime is the same thing as g prime times f. But also, addition is commutative. 3 plus 4 is the same thing as 4 plus 3. So really, if you set it backwards, quote unquote backwards, it's still forgiving in that you will still get the same answer, okay? Now, am I saying that you could write it however you want? No. Please don't. There's a reason why, because later on when you learn the quotient rule, it's not so forgiving. Okay, so just stick with this order so that the quotient rule makes a little bit more sense. Okay? All right, so here we go. Let's apply the product rule. Okay, here's example 1. Call this example 1. Find f prime of x if f of x equals 6x cubed times 7x to the 4th. So let's apply it here, okay? So notice how we have a product. It's something times something else, right? So this is kind of like the first and this is kind of like the second. So here we go. I'll write it out just so that we get familiar with it. It'll be fg prime plus gf prime. First times derivative of the second plus second times derivative of the first, okay? And again, you keep doing it, and once it sticks, there's no need to write it anymore. But I'll leave that up to you guys, okay? So what happens here is the first is just 6x cubed. Whoops, sorry. So first is 6x cubed times the derivative of the second, I'll just leave that blank, plus the second, which is 7x to the 4th, times the derivative of the first. Okay, now here's what I'm doing, all right? I'm getting all the easy parts out of the way. So notice here, first and second, we're just pretty much copy pasting what we have here, okay? The reason why I'm doing this is because later when you guys get more complex equations or functions, by complex I just mean a lot more terms, okay? It can be a little bit overwhelming, so this kind of reduces down on that, okay? So now I can kind of center in on what I need to focus on. Okay, if I'm looking at second, I need to find the derivative of the second. What is the derivative of 7x to the 4th? Pause and play when you're ready. That is just 28x cubed. All right. Now over here, I need to find the derivative of the first, which is this right here. Okay, pause and play when you're ready. What is the derivative of the first? That is 18x squared. All right. Okay. The rest is cleanup. Here we go. Right here, in the first term, we have 6x cubed times 28x cubed. Oh gosh, here we go. 28 times 6 is 48. Carry the 4. 6 times 2 is 12. Plus 4 is 16. So that's 168. And then how many x's do we have? We have x cubed times x cubed. That's x to the 6th power. Okay, when you're multiplying with the same base, you add your exponents. Okay, over here, that's 7 times 18. That's 56. Carry the 5. That'll be 126. That's 126. And x to the 4th and x squared gives us x to the 6th power. And since they both share the same power, we'll just add it. That's just how many x to the 6's do we have here? We have 168 plus 126. Oh gosh, 14, 9, 294 x to the 6. Okay? And that's our answer. Again, don't waste too much time on the multiplying part because that's very minor in terms of the calculus. And that's it. Here's what I want you guys to keep in the back of your mind, though. Now, in theory, f of x, we have this. Couldn't I have just multiplied it out first? Right? If I multiply it out first, 6 times 7 is just 42. And x cubed times x to the 4th is x to the 7th power. Now, did I take that derivative? Okay. All I did was I simplified it. So I don't want to call this f prime. I just want to call this f of x. Now, isn't this a lot easier to find the derivative? That's just 42 times 7x to the 6. Right? You move the constant multiple to the side, and 42 times 7 is 294x to the 6. So I ask you guys, which way is easier? Right? And I'm sure a large majority of you guys would say that this first method was easier. Right? So here's the thing. You guys had the product rule, but in this problem, was it efficient? Right? It was way more efficient to just multiply it out first and then find the derivative, right? So in this problem, product rule was possible, but was not efficient, okay? And the only way you're going to figure out what's more efficient is through exposure. You guys got to practice a lot of problems, okay? To kind of see what tends to be a lot easier without the product rule or with the product rule, okay? So just keep that in the back of your mind. Here's part B. Write it down. Okay, now here, based on what I see here, seeing that these are all monomials, meaning they're just one term times one term, I would probably just multiply this one out and then take the derivative. But just for the sake of getting comfortable with the product rule, okay, we'll use the product rule, even though it's not efficient, all right? So one thing I want to say first is, maybe we should rewrite this so that we don't have any actual roots. So go ahead and rewrite what that second function should look like. Pause and play when you're ready. Okay, so in case you forgot, it's going to be power up over index. Power up over index, okay? So the 4th root of x cubed is the same thing as x to the 3/4, okay? Right, we have a product, so let's find the product rule. Okay, so let's try without writing it out. So remember, the product rule is the first times derivative of the second plus the second times derivative of the first. Feel free to pause and try this on your own or follow along with me, okay? So the product rule is the first times derivative of the second plus the second times derivative of the first, Okay, I take care of all the easy parts first. Okay, so here is g prime, or the derivative of the second. That's just 3/4 x to the negative 1/4. If you're unsure, pause, take your time, and try to figure that one out there, okay? Over here, the derivative of the first is going to be 20x to the 4th, okay? Now, for now, we're just going to leave this here, all right? You can definitely simplify this, but I'm not going to, because my main concern for you guys is just knowing how to apply the product rule. Because really the rest is just algebra that we could always work on later. Okay, not to say it's not important, but the product rule is more important, okay? And once again, we applied the product rule, but keep in mind that based on this, it was probably more efficient to just multiply it out first. So 4, we're going to add 5 3/4. Oh gosh, whatever that is. That's going to be to the 23/4, and then you could just apply the product rule there, which is 4 times 23/4 x to the, oh gosh, 19/4. All right. Now, I don't expect you guys to go as fast as I am. You will eventually, but just go at your own pace. All right. You guys are seeing this for the first time, so yeah, don't be too focused on speed. Focus on accuracy first, okay? All right, here's part C. Okay. Once you write this down, answer this question, okay? First of all, we have a product, okay? Is it more efficient to apply the product rule, or should we simplify it first and then apply the derivative, okay? Pause and then press play whenever you're ready. Now, we do have a product and we can apply the product rule, but because these are very simple one-term functions, it's probably easier to just combine it, okay? That's pretty much just 3x to the 6 over x squared. And if you guys remember laws of exponents, if you're dividing with the same base, you subtract your exponents. So you get 3x to the 4th. And then you could just take the derivative there, right? Which is 12x cubed. But let's do it the more difficult way, just for the sake of the product rule, okay? So here, f of x, I noticed that 1 over x squared doesn't look like a power. So how do I rewrite that, okay? Pause and play when you're ready. 1 over x squared is equivalent to x to the negative 2. When you have a fraction, you could just use a negative exponent, okay? Okay, so here's the product rule. The derivative of a product is pretty much going to be the first times derivative of the second plus the second times derivative of the first. So the first times derivative of the second plus the second times derivative of the first. Okay, notice how I always take care of the easy parts first. Some of you like to go in order. Okay, that's fine, but I promise you it will get a little bit more complex when you're dealing with larger functions in terms of terms, okay? Okay, here we go. So first is x to the negative 2 times derivative of the second. That'll be 18x to the 5th plus the second times derivative of the first. That's going to be negative 2x to the, think about what this exponent is, okay? Remember, we're subtracting 1 from the exponent. So negative 2 minus 1 is negative 3. If you put negative 1, you got to be careful, all right? And like I said before, we'll just go ahead and stop there. We won't worry about the simplifying until later. And you guys will be doing it the same way with the homework, okay? Generally, my rule is if it's simple enough to simplify, then just do it. If it looks super complicated, leave it. Okay, so in this case, I mean, we could definitely simplify this just to show you. This is going to be 18x to the third power. Negative 2 plus the 5 will give you positive 3. Over here is going to be a negative 6x cubed, and that'll just give me 12x cubed. Okay? This is something that I would consider simple because you're just dealing with a base of x, but it does get a little bit more complicated later, which I encourage you to just leave after you apply the product rule, okay? All right, so part D. Take a look here. Now, here I have a product, all right? I can apply the product rule, or I can distribute the heck out of this and then take the derivative, okay? But notice if I try to distribute this, I have 6 multiplications I have to take care of, along with combining like terms, and then I take the derivative. Probably not the most efficient way. So this is what I mean. Sometimes, you could simplify it, but why if the product rule will do the same job for you, okay? So here we go. We're just going to leave it as is, okay? Pause and play when you're ready. Do this on your own, okay? So here, the derivative is going to be the first. Make sure you guys use parentheses. Times derivative of the second plus the second times derivative of the first. Okay? The derivative of the second is just 2x plus 3. That 1 goes away because it's a constant. All right? Okay, now the derivative of the first is just 12x squared. That 7 goes away because it's a constant. Okay? And that's it. And this is what I mean. There's a lot of terms going on here. I don't want you guys wasting your time on anything that's not calculus. Okay? Unless we absolutely need to. This here is just going to involve a lot of distribution, a lot of combining like terms. But again, our main focus is you guys learning the calculus, okay? So hopefully that was good. Okay, example 2. Go ahead and write this down in its entirety here. Pause and play whenever you're ready. Okay, so you will see this a lot on your AP exam, all right? There's no function here. Well, an explicit function, I should say. Like they didn't write it out explicitly like we had here. They just tell us that h of x is x times another function. Okay? So it's very abstract. So here's what you do. H of x is just, I'll color code this so you guys can see, x times g of x. Right? They give us all these conditions. Now, the number one mistake people make is they look at this too early. Okay? They want to start plugging stuff in right away. Don't plug anything in until I tell you to, okay? So here's what we do. H of x is x times g of x. X times g of x is a product, so we have to apply the product rule. They want us to find the derivative of h specifically at 3. But now let's just find our general derivative here, okay? So if I want to find the derivative of h here, I have to apply the product rule. So that's going to be the first times derivative of the second plus the second times derivative of the first. So even though we don't know what g of x is, we can still write it, right? Okay, so here we go. The derivative of the second. So what is the derivative of g? How do you write that, right? That is just g prime of x. That's the derivative, okay? Now the derivative of the first, what's the derivative of x, okay? Now, people tend to flip out with x. Remember, y equals x is diagonal line. Can you find the slope of that line? Because that's what derivative means, right? There's an invisible 1 in front of that x. That is your m. Y equals mx plus b. Your m is your slope. So the derivative of x is really just 1. You know what? Let me take care of that out of the way. If your function was 5x, your derivative is 5. If your function was negative 2x, your derivative is negative 2. So if your function is x, your derivative is just 1. It's just a coefficient. All right? Okay. Once you find your general derivative, that's when you move on to something specific, okay? So exactly where am I interested in? I want h prime of what? I want h prime of 3. So pretty much wherever you see an x, you're going to plug in 3. And that's pretty much it. So I'm replacing every x I see with a 3. There are 3 cases where there's an x, so I'm going to plug it in 3 different times. Okay, so here we go. That's 3 times g prime of 3. Well, they told us g prime of 3 is equal to 2. So I just plug in 2. Plus, well, g of 3, they told us it was 5. So I'm going to plug in 5. Okay. You multiply this out, eventually you're going to get 11. Okay, 6 plus 5 is 11. You see a lot of this, all right? So my advice, go general first and then go specific. Don't plug anything in until you go specific, all right? Cool. Very important one to remember. Okay. Here's the next rule, the quotient rule, okay? It's lengthy, so let me rewrite this for you guys so that it's easier to understand. D over dx, and instead of the f of x and g of x, I'll just write f over g. So notice when you're dividing here, you have a quotient. And if you're taking the derivative of a quotient, you have to apply the quotient rule, okay? So it's going to be g f prime minus f g prime all over g squared. Okay, just write that down first, and then I'll teach you how to memorize this here, okay? Okay, so here, instead of using the words first and second, it makes a lot more sense to use top and then bottom. Because with a fraction, you have a numerator and a denominator, okay? So a top and then a bottom. So a little bit of a history lesson here, okay? The derivation of this rule, okay? You guys may have heard of him. His rapper name is Drake, okay? And if you guys don't know, before he was a rapper, he was acting, okay? If you guys ever heard the show Degrassi High, he was an actor for that show. He was a kid in the wheelchair. Now, right after the show, and before he went into rapping, he went to college. I don't know if you guys know that. Yeah, and he was actually a math major. And he was actually one of the contributors to this rule right here. Right? So look, here's how this works. So you remember Drake came out with this song, right? Drake always likes to start it where? And you guys are probably not laughing right now, but just in case you're not familiar with Drake, Drake always likes to start it from the bottom. It's kind of corny, okay? I'm a parent. I'm allowed to give dad jokes. So here's how you remember it. The quotient rule is really just Drake's rule. all right? Because Drake always likes to start it from the bottom. So here's how you guys read it, all right? It's the bottom. You start it with the bottom times derivative of the top minus the top times derivative of the bottom all over bottom squared. Okay? It's kind of like the product rule in that they take turns. So bottom times the derivative of the top, and then they switch top times derivative of the bottom, but then there's a all over bottom squared. So say it a few times before we move on here. It's you started with the bottom times derivative of the top minus the top times derivative of the bottom all over bottom squared. Okay, so here's the thing. We have multiplication here, okay? We discussed earlier that multiplication is commutative, meaning that the order is forgiving, right? Now, is subtraction commutative? And if you don't understand my question, what I'm asking is, does order matter when you're subtracting? Is 4 minus 1 the same thing as 1 minus 3? Sorry, 1 minus 4. Is that the same thing? And I'm hoping by now you guys will say, no, it's not the same thing. So you got to get the order precisely here. Back with the product rule, it was very forgiving in that if you kind of mixed up the order, you could still get the right answer. With the quotient rule, you got to be spot on. So just remember, you always start at the bottom. Okay, so bottom times derivative of the top minus top times derivative of the bottom all over bottom squared. And you say it as often as you need to until it sticks, okay? Okay, here we go. Here's example, oh gosh, I'm going to call this 3. I could be wrong. All right, write it down and then we'll talk about it. Okay, so y equals that quantity up there over this quantity down here. I like to put parentheses, okay? So I definitely have a quotient. So the derivative, I would have to apply the quotient rule. So I'm going to write it out first so that we get the hang of it. Say with me here, okay? The quotient, you start from the bottom times derivative of the top minus the top times derivative of the bottom all over bottom squared. All right, so here we go. Y prime equals the bottom times derivative of the top minus the top times derivative of the bottom all over bottom squared. I took care of all the easy parts where it didn't require a derivative. Okay, now if you're trying to go in order, this can be very overwhelming and you kind of lose track of what you're dealing with here, okay? So again, I encourage you guys to take care of the easy parts first. So we took care of the bottom, the tops, the bottom squares. Okay, so now we have to take care of the derivative of the first. Take a look at, the derivative of the top. What's the derivative of the top? That's just going to be 2x plus 1. Okay, and then we're going to go ahead and take the derivative of the bottom here. What's the derivative of the bottom? That's just 3x squared. All right. So question, do I want you guys to simplify this? Please don't. You probably can, okay? But don't, because we're focusing more on the calculus than we are with the evaluating part, okay? So here's the thing. You guys got to be careful when you check your answers, especially on Slater, right? They're going to, on Slater, I assume they're going to go all the way down to the very end, which I don't want you to. So make sure that you guys look up your answers carefully, okay? All right. So here's some follow-up questions for you. And the reason why I do this is because people tend to miss this part, so I want to address it. Take a look at this problem here. What is the easiest way to find the derivative? What is the easiest, most efficient way to find the derivative here? Pause and play when you have an answer. Okay, the most efficient way here is probably just expand that. So I would distribute first and get x squared plus 7x plus 12 once you FOIL that out. And then taking the derivative is just 2x plus 7. That's probably the easiest way. I would not use the product rule here. Okay, only because we recognize this so well, all right? Let's take a look at this one. F of x is 1 over x cubed. That is a quotient. So, should I apply the quotient rule? So here we go. F prime of x equals the bottom times the derivative of the top minus the top times derivative of the bottom all over bottom squared. Okay? The derivative of the top, the derivative of 1 is just 0, and the derivative of the bottom is 3x squared. Okay? Well, x cubed times 0 is going to go away. And I'm just going to have negative 3x squared at the bottom. If I square x cubed in the denominator, I'll get x to the 6. And if I clean that up, if I divide with the same base, I subtract my exponents, I'm going to get negative 3x to the negative 4th. Or if you reduce out 2 x's, you're going to get 4 left here. So that'd be negative 3 over x to the 4th. Is that the most efficient way? And I hope you say no. 1 over x cubed is the same thing as x to the negative 3. If you rewrite it, you can avoid the quotient rule, right? And the quotient rule is super long, so you want to avoid it as much as possible. So the derivative here is just negative 3x to the negative 4th, in which you can move that base down to the bottom since it has a negative exponent. Okay, so you guys are doing multiple things today. You're learning the rules, but also you're learning about efficiency. Okay, hopefully you guys are getting the hang of this. Now these two are my most popular ones. Let's start off with this one. F of x equals x over 4. We have a quotient here, obviously, something over something else. Should I apply the quotient rule or should I simplify it somehow? Okay. Now, the only reason why people would lean towards the quotient rule here is because they haven't seen enough. So this is what I'm trying to get you guys to do. I want to get you guys exposed to this. Get used to this, all right? X to the 4th, there's a 1 in the front, right? That's the same thing as 1/4 x. Okay? So the derivative, kind of like if your function was 5x, what would the derivative be, right? It would just be 5, the coefficient. So here the derivative would just be 1/4. All right? You could totally avoid the quotient rule, which takes forever. Go ahead and try this one here. F of x is just 2/3 x, so the derivative is 2/3. Okay. Now, one thing I'm going to point out, make sure you're labeling it correctly. If you're simplifying it, don't call it the derivative. Okay, I see some people doing that, so watch out for that. All right, make sure you're accurate with what you're writing. Okay. Here's another example. Here, we can rewrite to avoid the quotient rule. Okay, you guys saw that earlier. And then you could just take the derivative there, which I won't do. Now here, it's a little bit tougher to see. But usually when you're dividing by a single term, you could probably avoid the quotient rule. And here's how. 3x squared and 2 radical x can each be divided by that x there. Okay, kind of like when we dealt with the limit definition of a derivative, okay? So here, 3x squared divided by x is just 3x because 2 minus 1 is 1. Now here, I'll write on the side, that's 2x to the 1/2, and at the bottom it's 1. So If you divide with the same base, you subtract your exponents. That's going to be 2x to the 1/2 minus 1. So top minus bottom, that's going to be -1/2. And we'll leave it there. You could simplify some more, but who cares? All right. But in short, we avoided the quotient rule. All right. This one here, let's call this part, oh gosh, example, you guys will know that I always lose my count. Example 10, all right? The derivative here, definitely a quotient, but can I avoid it? Absolutely. Think about how you would avoid it. D over dt of what? Pause and play when you're ready. T cubed is in the denominator, so we could actually bring that back up as long as we apply the negative exponent. Okay? And that'll just be -18t to the -4, which is -18 over t to the 4th. All right? And again, you guys will have a lot of practice in your homework assignments, all right? Okay, here's another one, part B. We have a quotient, but can we avoid it? The answer is yes. Okay, we'll take it one step at a time here. Just take a look at the bottom. How do you rewrite that, right? That's really just x to the what? We power up over our index, okay? Now, that's still a quotient. Can I avoid it? Absolutely. When it's down below, you can bring it back up as long as you apply the negative. Now, all of this here is equal to y. So make sure that you're writing equivalent statements here. So y prime is going to be -2/3 x to the -2/3 minus 1, which is the same thing as -5/3. Okay? You can rewrite this. You can bring it down below. And then you're all done. Okay, hopefully it's getting a little bit better each time. Okay, so real quick, let's say y was x squared plus c. All right. If I'm finding dy dx, the way you read this is the derivative of y with respect to x. That's what the dx means, okay? With respect to x. So what that tells you is that x is the variable here and the only variable. So everything else that looks like a letter, you have to treat it like it's a value, okay? So in this case, the derivative of x squared is going to be 2x. C is just another letter, so we have to treat it like it's a number. So what happens if this was like a 4, right? What's the derivative of 4? That would just be 0. Okay? Now, if I have y equals x squared plus c, and I wanted to find dy over dc, I have with respect to c, meaning c is my only variable, and any other letter will be treated like a constant. So the derivative of c is just a +1. X squared, even though it has an exponent, remember x squared, if I treat x as a 4, 4 squared is 16. What's the derivative of 16? 0. But we don't need to write that, right? So your answer is just 1. So pay attention to the notations. It doesn't happen too often, but I just kind of wanted to address that to you guys now, okay? Let's do... I'm thinking, hold on. Let's do this last one right here, okay? Example, we'll call it 12, all right? Pause and play when you're ready. So we've seen this before. Find equation of the tangent line. Normal line we'll get to. Just put it on the back burner for now, okay? Okay, so we want to find the equation of a line, a tangent line, all right? So recall, what two things do you need to make an equation of a line? We need a slope and we need a point. Okay, we did this in the last few lessons, right? So we already have a point, 1 comma 1/2. All we need is a slope. Well, how do you find the slope of a tangent line? Slope of a tangent line is your instantaneous rate of change, also known as your derivative, right? So we need to find y prime here. Okay, so here, can we avoid the quotient rule? Because there's a quotient right there. We have the square root of x all over the 1 plus x squared, right? So there, since there's two terms in the denominator, we're probably going to have to just use the quotient rule. So here we go. Quotient rule is we started with the bottom times derivative of the top minus the top. I'll write it as x to the 1/2 times derivative of the bottom all over bottom squared, okay? The derivative of the top is just going to be 1/2 x to the negative 1/2, okay? The derivative of the bottom is just going to be 2x. Okay, so I'm going to clean this up a little bit. Right here, we'll smush it together. That is 1 plus x squared at the top. There's a 1 and a 2. That x and negative 1/2 can go down below. All right? Minus, here we're multiplying with the same base, so we'll add our exponents. So we have a 2 coefficient, and 1/2 plus 1 is just 3/2. Okay? All over whatever 1 plus x squared squared is, okay? Okay, so we did a lot. Don't lose the context, right? What did we just find? Like, what is the derivative? What did we just find? We found the general slope. Now, do we want to find the specific slope? We do. We want to find it exactly at 1 comma 1/2, all right? And I'm going to let you guys dabble with that. Whatever you get is going to be your specific slope. And once you have the slope, you can make your equation of a tangent line, okay? I'm going to stop there. We'll come back to normal lines later, okay? But that's it.